Okay, so we are continuing with our past paper from last year for AS level maths. This is the third variant of paper 1 from June 2021. I will put a link in the description of the video so that you can grab that past paper and actually do it with me. So if you are studying for your AS levels and preparing for the exam, what I'm going to be doing in these questions is giving explanations on how you do everything. So I might take a little bit more time. So if you do know what's going on, go ahead and actually do the questions by yourself. Okay. For those of you who don't know, you can just follow along. All right, so this looks very confusing, right? A function f is defined by f of x equals a third, 2x minus 1, blah, 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 blah. And it is given that the f is a decreasing function, Okay, so let's just unpack this question. We have a function. Okay, so that's fine. We know that would go on a graph. I don't really worry too much about what that looks like. Then they've told us that it's a decreasing function. Okay, so that's the key. Decreasing function. Well, what is a decreasing function? Well, let's just draw a parabola, for example. Well, we can see that it's increasing from on this side and decreasing there. So this would be increasing because it's going uphill. And this would be decreasing because it's going downhill. And they are telling us that it's a decreasing function, meaning it's going uphill. So forget about the decrease. It's going to look something like this. Okay, and I'm not saying this is not a parabola, but this is just showing you the idea that if a function is increasing, it's going up. And what does that mean? The slope is going up. Okay, so the slope is going up. So that's the key to this question. Slope is going up. Okay. And what do we know about the slope? The slope is our f dash of x, our derivative. Okay, so whenever you see these sort of questions, where you're seeing decreasing, and then the other key point, if you hadn't noticed the decreasing, the other big deal for these types of questions is maximum. All right. So the maximum possible value. Okay. So there's two things. One is we're looking at the slope is increasing, and so our derivative must be positive. And then the other thing is we want the maximum value of the constant. So in other words, if this is going upwards, if this function is going upwards, what is the biggest number that a can be? So what I'm kind of doing is I'm saying, if it's decreasing, why did I say, okay, pardon me. Everyone's probably noticed that. It said decreasing, not increasing. So this is decreasing. That's simple. Okay. We're just actually looking for a decreasing function. So what is that? That's our slopes going down. So in this case, if it's going up, our slope is positive, meaning it's greater than 0. If it's going down, our f dash of x is less than 0. Okay, so decreasing function, slopes going down, f dash of x is 0. So I don't have my f dash of x. So in the first question, we were asked to get the integral. Now we are asked to get the f dash of x, our slope. And we need to know that our slope, because it's going down, is less than 0. So at the end, we must just remember to bear this in mind here. Okay. So we have, this is our inside-outside rule for differentiation. So what I want to do, let's just write this out again. So fx, and this is what we call the chain rule. Okay, so I'm going to go through the chain rule. I'm going to go through it fairly slowly, so that someone who hasn't done this before can hopefully follow along. So what I like to do is, if you have a bracket with an exponent on the outside, in order to differentiate, you need to do what's called the chain rule. And I like to call it the inside-outside rule. So what we do is we talk about the inside as being whatever's inside the bracket, and then the outside as being whatever's outside the brackets. And we're going to differentiate that. And I'm going to do I'm not going to show you the formula. You can look up the formula for the chain rule. What I'm going to do is actually just do it in words so that we can avoid these kind of confusing maths terms. So when we have a bracket and then an exponent on the outside, what we do is, like we did with the power rule, we multiply the front by the exponent. Okay, so 3/2 goes in front, but that's the exponent. Okay, so let me just highlight that. So the 3/2 goes in the front. Actually, I'm going to rather do it in pink. So the 3/2 goes in front. And the 1/3 stays the same, because that's just a number that doesn't, you don't have to worry about. So the third stays there, but the exponent goes to the front. Then what we do is the inside we leave alone. So I'm actually doing, we should call this the outside-inside rule, because what I'm doing is I'm doing the outside first. So I'm saying the 3/2 times the 1/3. I leave the inside alone. So the 2x minus 1 stays the same. And then what I do is, because the power rule, so the inside-outside rule involves the power rule, which is, if you have x squared, what we do is we say 2 times x, and then we take 1 off the 2, so it becomes 2x. So in a way, what we're doing is we're just doing the power rule with the outside. Okay, so the 3/2 times the front, and then we take 1 off the exponent. So 3/2 minus 1 is a half. Check that on your calculator. So the outside-inside rule, let's call it the outside-inside rule, because I've done the outside. So I've said the 3/2 goes to the front, and then I take 1 off the 3/2. So I've technically treated this pink bit as a power rule, but I've left the inside alone. Now what I do is I multiply by the derivative of the inside. So the derivative of 2x is just 2. Okay, minus 2x, well, the derivative we know of minus 2x is minus 2, because that is the derivative of any number with just an x, is just that number in front of the x. So in other words, the derivative of a third x is a third. Derivative of 5x is 5. So derivative of minus 2x is minus 2. Okay, so we've done the chain rule in order to get the derivative. Okay, now what we notice is I'm going to do this again, exactly the same, but I'm going to do it the other way around, just so that you see that it's the same and you get the same answer. The 3's cancel, and this 2 cancels with this 2. leaving us with 2x minus 1 to the half minus 2. Okay, so I want to do it one more time, and I'm gonna do it the other way around, where we're going to do the inside-outside rule. So we're going to do the inside first, and this might be, so you could do it this way, or you could do it this other way, which you may find easier. The inside-outside rule. So let's see. So again, I'm doing the same thing. I'm just doing it in a slightly different order. The inside is the 2x minus 1. The outside is this bit here. So whenever I'm asked to differentiate a function which has a bracket with an exponent, so even this 2x plus 1, this would be chain rule, because this ends up 2x plus 1 becoming 2x plus 1 to the half. So just bear in mind that you could use this chain rule. You can use it for any function where we have the brackets and the exponent. Okay, so inside outside rule. So what I'm going to do is the inside first. So the derivative of the inside, 2x minus 1 is 2. Let's do that in blue. So I'm doing inside first, inside outside first. So now I do the outside. Okay, well, the third stays. Then what I do is multiply by the 3 over 2, multiply by the exponent. Then I leave the inside alone. I actually prefer this way around. And then the 3 over 2 minus 1 becomes a half. This is a 2x here, becomes minus 2, the derivative of that. And so we see when we times this out, 2 times 3 over 2, the 2's cancel, the 3's cancel, and I'm left with two x minus 1 to the half minus 2. Well, I'm not quite done. That is the derivative. But they are telling me what is the biggest number that a can be when x is between a half and a. And so what I have to do is I'm going to say, well, what if it's a decreasing function, what does that mean? That means that this derivative is going to be less than 0. Because we know that if it goes downwards, it's less than 0. So it's sloping downwards. So what I have to do is I have to say, well, if this is f dash of x, that must be less than 0. So what I do is I will say that 2x minus a half minus 1 to the power of a half, this derivative that I just found, must be less than 0 if it's decreasing function. And I actually am going to solve for this. Well, the 2 goes to the other side, and I get this. Now what I can do is I want to get rid of this half. Well, remember that x to the half is the same as the square root of x. And what do I do to take rid of the square root? I just square it, right? If I square root a square root, I get rid of that square root. So what I'm going to do is I'm going to square both sides. Square this and square this. Okay. Running out of space, I'm going to put this now over here. So once I've squared it, I get 2x minus 1, because the square root, the power of a half has gone away, is less than 4. Now I take the 1 to the other side, I get 2x to the 5. Okay. Now, I divide through by 2 to get x by itself. Divide by 2, divide by 2. And so then x is less than 5/2. Okay, so what is the biggest number that a can be? Well, look at this. This looks exactly the same. See this? And you see this? Exactly the same. So a must be 5/2. So a equals 5/2. Okay, so that's question 2 down. Hopefully you found that simple. I know that I went over it quite a lot for quite a long time. I even did 2 different orders in which you can do the inside-outside rule or the outside-inside rule. And then you can make a decision over which you prefer. I prefer the inside-outside rule. So derive the inside first and then do the outside afterwards. Okay, if you found this very confusing, just keep practicing. I'm going to be doing more memo questions in that. And so the second, third, and fourth time you watch it, it'll get more and more clear. So subscribe so that you can get those answers and explanations. Okay, so in the next video, we're going to be doing question 3 of this past paper.